Welcome to Curious Tech World. In today's video, I will be discussing Maglocks. This is the first video in the Access Control series, and to kick it off, the Maglock seems to be the fitting choice. I think most would agree that magnets are pretty cool and fun to play with. An electromagnet is no exception. This Maglock is a Seco-Larm 1200-pound Maglock, which means it has 1200 pounds of holding force. This model can accept 12 or 24 volts DC, depending on how you wire it up. For this video, I'm using 12 volts off of an alarm battery. Maglocks come in various form factors depending on the application. The demo model in this video is intended for outdoor use, and the major indicator of this is the pre-made whip along with the threaded nipple at the end of the lock. A Maglock is an electromagnetic device. There is a large coil of wire within the device, and when energized, it produces a magnetic field. So let's go back to the holding force of this Maglock. I mentioned it was 1200 pounds. That essentially means that you need 1200 pounds of pressure to overcome the electromagnetic bond. Your average adult human would not be able to break this bond. They do make 600-pound Maglocks, and I honestly do not know why. Don't buy a 600-pound Maglock. A quick shove of your shoulder could break the bond on it. When installing the lock, care for mounting, placement, and purpose means everything. Improper installation can lead to failure, poor bond, or undesired operation. The most important piece of advice is to check with your local authority holding jurisdiction or International Building Code, as well as the ADA, to verify that the installation of this lock is within compliance. Failure to do so can result in a life safety or fire code violation and end up being expensive and time-consuming to fix. Worst case scenario is someone could end up trapped in a building during an emergency. In an event like that, legal troubles can come down on the property owners as well as the installers of the locking devices. Let's discuss the operation of the lock. It is very straightforward. You have the lock body and you have the armature plate. When installing the lock and the armature plate, they will be perfectly aligned to ensure a full rated bond for the magnet. The armature plate will be installed using provided hardware that firmly holds the plate to the door but still allows for a horizontal rocking movement. The movement allows for the lock to reach out and take up the armature plate. I've seen where installers have firmly bolted the plate to the door and the door is not exactly perpendicular to the lock. The bond between the lock and the plate never holds. Not to forget that doors do not hold the same shape or alignment after repetitive use. So I guess what I'm saying is read the instructions. Next, let's talk about the electrical part of the lock. This lock I'm using can use 12 or 24 volts direct current. A lot of brands you get today have this variable voltage capability. Another nifty thing about newer locks is they contain circuitry that protects the lock and prevents damage. One such component is an MOV or metal oxide varistor. Varistor? Either way, this part used to be shipped with older Maglocks, as the lock you purchased would be nothing more than an electromagnet. Over the years, lock manufacturers have begun to produce self-contained electronic locking devices, which is just another way of saying a Maglock with some circuitry. So it was up to the installer to add protection circuitry such as diodes or MOVs. An MOV has resistance that varies with the voltage applied. It will have a resistance for both directions of current, and when used in conjunction with a Maglock, it will essentially protect the magnet coil from excessive transient voltages. If you've encountered a Maglock that holds a bond after voltage has been removed, chances are there isn't an MOV. For the last part, let's discuss failure modes of a Maglock. The best case scenario is the lock just stops working, but that's not always what happens. In some cases, the lock can begin to overheat, and this is usually due to the coil starting to break down. When a Maglock heats up, a couple things are also true. The lock has a weaker bond, and it's drawing more electrical current. Due to this overheating, the lock can catch fire. The MOVs will burn up, and if you have additional locks utilizing the same power source, it can cause them to also fail, either due to overamperage or lack of current. It's taking some time to produce these videos, but I will have some more out soon. I hope you enjoyed this one, and if you did, please subscribe. See you next time.